Welcome to the CHEM 1411 Lab Flow workshop. Today, we will explore the experiment number 2, which is chemical and physical properties. The main objectives of this lab are first, to make observations of different elements and chemical reaction, and to be able to describe your observations and construct a hypothesis. Please stop me anytime, just send me a message or unmute yourself with any questions that arise. The idea is to communicate with each other, so when the time comes for you to do your report and your quiz, you are ready. So let's continue. So here in the objectives, those are the main objectives. Basically, is observations. For example, when you mix, there are different parts in the reports that we are going to go over, A, B, C, D. In one section, you mix a piece of copper metal with a colorless solution of silver nitrate. We will go over that. And you observe, so you will have to, I will guide you to learn how to observe, what to observe, and how to take notes. So after 10 minutes, when you mix that colorless solution with a piece of copper, you start to see that the surface of the copper changed to a silver color. And the solution that was colorless is now light blue. So what happened? And that is when you are going to start guessing. You might guess that there was a chemical reaction, and probably you're going to guess that there is silver metal now on the surface of the copper. You might also guess that the copper metal is now in solution because the liquid changed from colorless to light blue. So this is just an introduction on what is this experiment about. Observations, observations, observations. And another important thing that you are going to learn after this workshop is to be able to differentiate between a physical property and a chemical property. And also what to look, what are the visible changes when there is a chemical reaction. So here in the this is the write-up of your experiment. So I'm trying to go over the main areas that I highlighted. Here it says that each substance is different. It says the characteristics that distinguish one substance from another are called properties. If you take you have the periodic table, each element is different from the other. If you take a piece of gold, it looks different than if you have table salt. So those characteristics of each substance are called properties. And we divide the properties into physical properties and chemical properties. And you will need to be able to distinguish when it's a physical property, when it's a chemical property. And what is the difference? Here is highlighted. A physical change occurs when matter is transformed in a way that does not alter its chemical identity. What does all mean? Basically means that when you measure a physical change, the identity of the substance does not change, the chemical identity of the substance. For example, if I add salt, table salt, to water, the salt dissolves. Before I had the powder, the salt, and I had the water. Then it's all one solution, but still, I didn't create any new substance. I have the water and I have the salt. So physical changes, when we measure physical changes, it doesn't change the identity of the substance. So basically, that is what you all need to retain. For example, color. Look at the color. I can tell which color is a substance without changing the identity of the substance. Here are some examples: color, melting point, boiling point, odor, hardness, texture, solubility, electrical properties, density of a substance. All those properties are characteristics, are physical properties of a substance. Before we move on, I want you to be familiar with melting point, boiling point, odorness. Those are all physical changes. Why they're physical changes? If I have a solid and I heat it up, I melt the solid and I change the state, the physical state, from solid to liquid, I still have the same substance. It's just a change in the state of the solid. So all is a physical property. Let me go here to share the screen. And any questions so far? Okay. So then we'll go to chemical properties. Chemical change. That is, when we have a chemical change, we are making a new substance. For example, here is flammability. They're giving us some examples: rusting, explosiveness. Once, if we want to measure, for example, the flammability of a substance, well, we have to make the substance burn. And after the substance burn, we don't have the same substance anymore. There is a chemical reaction with oxygen to produce a new chemical, a new substance, and that is a chemical change. So we will go over some practice during this workshop to make sure we know, we all understand what is a chemical change and what is a physical change. Then there is another thing that in this write-up that the students need to learn, which is the word miscible. When are two liquids miscible? Well, what does that mean? Means that when you mix two liquids and you look at them, they look completely uniform. You don't see the difference. That means that they are miscible. But if you mix two liquids that are not miscible, you are going to observe two layers that form in the liquid with a little line in between. And the liquid with higher density is going to be on the bottom. For example, when you mix oil and water. They are not miscible. They are immiscible. That's why you see the line in between. They cannot mix. And another term that you are learning in this experiment, you will use it a lot, you need to be familiar with when a solid is soluble. When we add a solid to a liquid and the solid dissolves in the liquid, we need to know that we call that soluble. We say that the solid is soluble in the liquid. If I add table salt to water, it's soluble. But if I add sand in the water, it's not soluble. And then I will have two phases. Let's say that I add salt to water. How do I call that mixture of that solid that is dissolved in the water? I call it solution. Get familiar with that term. You are going to use it a lot. You are going to learn how to calculate the concentration of a solution. What is the concentration? It's how much solid is dissolved in the liquid. You can express the concentration in many ways, and you will learn that during the semester. But for now, just learn what is a solution. It's basically a solid that is dissolved in a liquid. How do we call the solid? The solute. How do we call the liquid? The solvent. The solute and the solvent make a solution. Any questions so far? Okay. Let me share here. Okay. And the last part of the write-up here is about we said that when a chemical change or a reaction occur, we said that new products form. We know that. But when you are going to do your report, or if you are in a lab, in this case, we will do it together. We'll have to look at a video. But anyways, in the lab face-to-face or in the video, what signs, what do you have to look? What are the visible changes that we need to observe? Because all this is about observation and be able to describe the changes. Well, we're going to be alert. Here is highlighted. It says formation of a precipitate, a solid product. So what is precipitate? Because all these terms, this is Chem 1, and I know you are just getting familiar with those terms. It's not that easy. So you hear precipitation. What does that mean? Well, it's a solid. Let's say you mix two liquids, two clear liquids, and all of a sudden, when you are in the lab, you look at the mixture of these two liquids and you see a solid product. Or sometimes we observe a cloudy appearance. It looks cloudy because the solid is finely divided in the solution, and you don't get to see a separate precipitate. Why do they call it precipitate? Because when you mix the two clear solution, it's like the precipitation, the rain. Okay, when you mix the two clear solution, it's like it fell out of the solution as the rain falls out of the sky. So you see the formation of a solid. So that is one sign. If you see that, okay, you said, I have here a chemical reaction. What other signs we have to be alert, especially when we are going to watch the videos? Formation of a gas. If we see bubbles that are in the solution, that are going out of the solution, okay, the formation of a gas is another indication that we have a chemical reaction. And here it says it calls effervescence. We all know sometimes I take vitamin C and I put the little pill inside the water and you see effervescence. Or when you open the carbonated water, we see the formation, the CO2, that is the gas, and the bubbles that comes out of the solution. So we talk about the precipitate, the gas. What else is in here? It says color change. Of course, if you put two solutions that are clear, for just as an example, and you see a different color, a new substance is another indication, is a visible change that a reaction occurred. Now, when we say, just to clarify, when we say it's a clear solution, that means you can see through the solution. But when we say it can have a light blue color, but it's a clear solution, that means you can see through. But if it's a colorless solution, it's like water, has no color. I just wanted to clarify that. Okay, let's go back to our visible changes. One is a heat evolved. Heat evolved, we have to be careful. But I want to say that is a sign that a chemical reaction occurred. It is a sign, but not always. So if we say that the chemical reactions always create heat, no. But if we say that the heat is an indication of a chemical reaction, yes. Many times heat evolves when there is a chemical reaction. So take it with a grain of salt, but yes. And then the change in odor. If you see that there is a new odor, okay, that's an indication that a new substance might be created. So this is the write-up. Let me see what else is in here. And here, basically, starts procedure. So I will go through quickly. Most of the report is about observing the reactions and different elements and basically communicate them in the report, how to write your observations. And as you see here, the report has different parts from part A to H. We will go over a blank report. And we will start now looking at here. So before I move to the blank report, I want to show you what is all the experiment about and how are we going to solve this. There are some videos and some samples that we will have to look that they are provided in this lab. For example, part A. What is this about? Select 8 different elements and you're going to be given the different elements and you will have to observe these elements. So here, let me see if you can see that because okay, yes, you can see that screen, which is a good thing. So here you will be given, when you click in LabFlow where it says sample data, all that sample data is only for part A. So basically, they are showing you, let's say, this first element, nickel. Okay, so you will have to complete by observing this element, what is the color, and you will have to find out if it's a metal, what is, if it's solid, how does it, basically, how does it look? That will be the color, and it will ask you for the atomic number. So we will go over that, but you will use this part to observe the different elements: tin, bismuth, magnesium, iron. These are the 8 elements: cadmium, copper, aluminum. So they will give you this information. Let me go to lab flow. Okay. So this is how it's going to look, the report that you will have to complete. Part A, it says 1, 2, 3, 4, 5, 6, 7. And based on your observations, what are the general physical properties of metals, non-metals, and metalloids? So let's look at part A. Here, name. You're going to click on number 1. Number 1 is going to be the same, the first element, which is nickel. Okay. So here, trying to zoom, trying to make it smaller, but it's very. Okay, can you see the screen, the periodic table? I want to make it. Can you see the periodic table? The whole periodic table or just part? When you see the periodic table, oh, great, awesome. Okay, thank you. So let's look at the periodic table just to have an idea. This periodic table if you see, you can zoom in on your side, has different colors. So all the elements, these are all the elements. The ones that are in yellow, here it says they are all metals. The ones that are in purple are metalloids. And the ones that are here on the upper right in a greenish color are non-metal. Most of the elements, as you see, the majority is yellow, so the majority of the elements are metals. And then there is another thing that we have to look. If the symbol of the element is written in black, the element is solid. If the symbol of the element is written in blue, is liquid, and if it's written in red, is a gas. Okay, so in our report, the first element in the sample, number 1, is nickel. So you go to the periodic table and you try to find nickel. We find nickel. Can you tell me what is the atomic number of nickel? That's one information that you will need to provide in the report. You can message me. Can you find the nickel and tell me in this periodic table what is the atomic number of nickel? Okay, here it says 14. No, exactly, cannot be 1401. Why? The atomic number, it's a whole number. The atomic number is not the molar mass. Yes, awesome. 28. That's great. Exactly. So you are going to come when the first element, you're going to say 28. This is the atomic number. By the way, what does the atomic number mean? It means how many protons are in the nucleus. And that will basically determine the characteristics of nickel. Nickel is nickel because it has 28 protons in the nucleus. Copper is copper because it has one more, has 29. And of course, because the nickel has 28 protons, it will have 28 electrons around. If it's not an ion, if it has no charge, it's the same negative charges and positive charges. Very good. So we got to complete the atomic number in the report. And then the color. The color you are going to observe, there's so many. Basically, they are mostly shiny and they're mostly gray. So write whatever is closest to what you are observing. You can also help yourself trying to find out more information about that metal. And then there is another column that you have to complete for nickel, and it's asking you if it's a metal or a non-metal or a metalloid. Obviously, what is nickel? It's in yellow, so what is it? It's a metal, it's a metalloid, or it's a non-metal? You can write metalloid. You said metalloid. When we look at here down, metalloids are in purple. Here down, I don't know if you can see here. Yes, metal. Awesome. Metalloids are only these. They're not that many. Boron, silicon, germanium, astatine. Sorry, arsenic, I cannot. Antimony, okay, I'm not gonna read them all. So metal, awesome, because so mostly are going to be metals. And then they ask you another question, another column, the state. What are you going to write? Because the nickel here, the symbol is written in black. So here, if it's written in black, it's a solid. So you are going to complete, they give you options, the report, and you are going to complete that. The second part, okay, you're going to observe in the sample, the second element is tin, and you are going to do the same thing. You're going to say, okay, Where is tin? Okay, here. They will ask you for the symbol as well. So you will have to write the symbol. So that's when you are going to use your periodic table to find out the symbol, the same thing, the atomic weight, the atomic number. What is the atomic number? 50 is this number of protons. And then you're going to complete the color, if it's a metal, and so forth. Any questions before we move to part B? Okay, so basically part B is, part A is clear. We are going to choose the element, the symbol, the atomic number, the color, the type, and the state. We know how to complete part A. And then here is going to ask you, based on your observations, what are the general physical and properties of metal, non-metals, and metals? That is something that you are going to look probably in your book, but in general, the metals are shiny. They are good, you learn it in the lecture, and you know by now that the metals are good conductors of electricity and heat. What other characteristics in general all the metals have? Well, the density and the melting point is high. And all the metals are solids except for mercury. Mercury, you know, we use it in our thermometers, it's liquid, but all the other metals are soluble. So you're going to look for information about metals. What is the difference within the non-metals? So they will give you a space here to write down about that. The non-metals usually are brittle when they are solid. They are not shiny, and they're not good conductors of heat or electricity. So that's things that you are going to find out from your lecture. And metalloids. What are metalloids? The general characteristic. Well, they look like metallic, brittle solids. They are basically semiconductors, and they have weakly acid oxides. But that's something that I'm telling you in general, but that's something you are going to look it up. The general characteristics of metalloids, non-metals, and metals. And then in the report comes part B. What does it say? Now is where it comes the skills of observing. Like if you are in the lab, you are going to do the experiment and you are going to observe and pay attention. What happens before heating? What happened during heating? What changes do you observe after heating? And here it says, sublimation of iodine crystals. First of all, what is sublimation? We have to learn how you call all the different changes. Sublimation is when you have a solid, you heat the solid, and it goes straight from the state of solid to the state of gas. So in this case, we will have iodine crystals in part B, and we are going to do sublimations of those crystals. And they are asking, record your observations for the sublimation of iodine for each stage. For example, below heating, during heating and after heating. So I will try to see, at least for the first one, to see if I can share the video of lab flow, because that's only 2 minutes, and let's see if that is possible. What do you see? Do you see just the lab flow screen? Okay, I don't see that for some reason. Okay. Okay. So what we are going to do is, this is the lab flow. The first one here is the experiment, the write-up. This is where you have to click to do the quiz. Here is the sample for part A, that we already went over that. And here we have parts B and C. So we are going to click on here, and we are going to do part B, which is the sublimation of iodine. Pay attention to that, and then we will talk about it. So we have to pay attention and look. And then we will have to describe before heating. For now, all it is happening, there she's turning on the Bunsen burner. She's preparing the heat. She has a beaker. And now she's adding into the beaker iron crystals. And they ask you, how do they look? They look dark purple, almost black before heating. And then she's starting to heat. And they ask you, what is happening during heating? Do you see? When these crystals are heated, you see a purple cloud that forms over the crystals. And then what happens when this cloud, look at that. Look, what color is that? What color are the crystals on the watch glass? They are dark purple crystals that form on the bottom of this is the next experiment, so we will stop. Before we continue, I want to ask you if you are ready after observing that video, if you are ready to complete the part B. Awesome, that's great. So basically, that is all about. Pay attention. What do you observe before heating, during heating, and after heating? And what do you see at the bottom of the glass? So let's continue. I try to share the screen to do part B. So this is part C. When you look at your report, part C basically is a reaction between copper chloride and aluminum. So look at the color of copper chloride. So you can watch it so many times. I'm just guiding you to see how to observe. So they are showing you how the color, how the copper chloride looks when it's added to water. The crystals sink to the bottom, and you see like a light blue color. And then what happens? You add aluminum foil. At the beginning, she's adding, nothing seems to happen. But as we pay attention, look, bubbles are forming. And what else is happening? Look at the surface of the aluminum. Is it the same color? Or is it darker? It looks darker. And then what else is happening? She has a thermometer inside that. Look at the color. Okay, so we are observing that the color of the aluminum foil is changing. What else? Look at the solution. When we started, the solution was colorless. And now, no colorless, sorry. Now it looks like at the beginning, when we mixed the solution, has like a light blue color. And look at the solution now. The blue color fades, it's almost colorless. So this is all about part B and C. And let's look at the next one, part D. Part D is mixing copper with silver nitrate. So here is part D until H. Mixing copper with silver nitrate. Look, silver nitrate has no color. And now a piece of copper. We add inside the solution. Pay attention. The good thing is that you can observe this as many times as you want. Look how the color is changing. The shiny reddish brown color of the copper are added to a colorless solution. And what happens? Look at the color of the surface of the copper. Has a different color. It's now silver. And the solution? Let's look what happened. At the beginning, looked like the solution is not changing the color. But now, it looks like it's getting a little, now we're going to stop here for now, a little bluish. Let me go back because I have to change the screen in order to change the applications. So let me read all the messages. Okay, awesome. Yes, it's here. Perfect. Okay, any questions so far on how you are going to complete this report? Okay, would you like me to continue going until the end with the video? Or just do some practice problems to make sure you are ready for the quiz? Or both? Okay, so I think you know how to complete the this report. And now what we are going to do is just a little practice. Not much, but just to make sure before we finish. Okay. So you are going to text me if you don't want to write much. The first question is about determine whether each observation is a physical change or a chemical change. So I will say the first one, density. If it's a physical change, you can message me with, unless you want to unmute yourself. So you can tell me physical or chemical. So let's go to the first one, density. Take your time. Is it a physical property? Is a physical change or is a chemical change? What do you think? Okay, you think it's a chemical. Why do you think it's a chemical? Let me see. What is density? Density equals mass divided by volume. Density is a property of each substance. When I measure the mass, I put it in a balance. Do I change the identity of the compound? No. When I measure the volume, do I change the identity of the compound? No. So how did we say at the beginning, when do we have a chemical change? Because you think it's a chemical change. Basically, when we produce a new substance, when we have a chemical reaction. Let's say I have a nail here of iron, and I leave that nail outside. It rains, and I come after a month, and the nail is rusted. Why is rusted? Because the iron combines with the oxygen to produce a oxide. You don't need to know the reaction right now, but it's a chemical reaction. The rust is an oxide. It's not iron metal anymore. That is a chemical reaction. And all those observations that you are going to do today or whenever to do the report, those are chemical reactions because you are observing a change in color. All those signs that we said that we have to observe, those are signs of chemical reaction. So now when we measure the density, I don't create a new substance. So do you think it's a physical change or a chemical change? Yes, exactly. So this is a physical change. How about flammability? Flammability is at what temperature is going to burn. You know, there's some alcohols are flammable. When you did the safety quiz, you learn that some liquids are flammable and they have to be kept in a flammable cabinet. Those because they burn at lower temperatures than others. So in order to know the flammability, to test the flammability, you need to burn it. When you burn it, you lost the original substance. Let's say I have ethanol. Just to say I have methanol, whatever. And I burn methanol. That is a reaction with oxygen. So it's going to produce carbon dioxide plus water. I'm not going to balance this equation. It's not the purpose right now. What the purpose is that you started with methanol. Here, the arrow means these are the products and these are the reactants. So methanol reacts with oxygen to produce carbon dioxide and water. So I started with methanol and I obtained a different substance. So flammability, you think it is a chemical change or a physical change? Let's see. Awesome. How about color? You have it in the write-up. Color, you say it is chemical. Why do you think it's chemical? In order to look at the color, do you need, when you look at the color of a substance, do you produce a new substance? In order to measure the color, do you have to produce a new substance? If the color changes, but that is different. When you mix, exactly, when you mixed two substances and the color changes, then you have a chemical reaction. But just a property. Okay, awesome. Just the color. Is the color, we said, is a physical, because you don't need to produce a new, you look at the color and you can tell. How about melting point? What is the melting point? What do we say is the melting point? Yes, awesome. When it changes the state, melting is when this is the temperature, when the solid becomes liquid. And we still have the same solid. We are not creating any substance. We are just measuring, like the boiling point. How about reactivity? In order to measure their reactivity, we have to make a chemical reaction. Otherwise, we don't know. We cannot measure reactivity without producing a chemical reaction. So that will be a chemical property. Let's talk about solubility. If somebody dissolves in water, I still have the same substance. I didn't create a new substance. So solubility will be a physical property. Now you are going to do the next one. Bubbles are produced upon mixing two solutions. What is that? When you see bubbles, you say, ooh, a gas is forming. Yes, awesome. That's an indication of a chemical reaction. How about the next one? A liquid freeze into a solid. Yes. How about the next one? A color of a substance changes over time. It's a change, and the color change. So you have a substance that, like is chemical, exactly, like the iron. I leave it outside and then the color changes. Yes, there is a chemical reaction. Very good. And now a solution heats up upon mixing with another. We said that the temperature, it's a sign, can be a sign of a chemical change. About a solid dissolved into water. Physical or chemical? A solid dissolved into water. So I put sodium chloride in the water, or I put table salt in water. Did I create a new substance? No. I still have table salt. What happens is that you have table salt, sodium chloride, the salt that you use in the kitchen. And then you have a little beaker with water. And you put the table salt in the beaker. The solid dissolves, and what you have is basically ions. It dissolves means the ions separate, but there is no reaction between the salt and the water. If I want to recover the salt, I can evaporate the water, and I didn't create a new substance. I still have the table salt. There is nothing new. So is it a physical change or a chemical change? I did not create a new substance. So when a solid dissolved in water, it is a physical change. Okay, because I didn't create. So basically, that's what you have to look. Are we creating a new substance? And all those videos that you are going to watch are mostly, except the sublimation, that you are only changing the state of the iodine, mostly are chemical reactions. The iodine, no, you're just subliming, just changing the state. That is a physical reaction. And let's look at the last one. A precipitate is formed from two solutions. That is easy. It's a chemical change or a physical change. You mix two solutions and you see a little solid here. Is it a chemical reaction or a physical change? Yes, awesome. That's a chemical change. Very good. And now, to finish this workshop, is one more question. What are the common indicators that a chemical reaction has occurred? Just to review, we said a change in temperature. If the temperature change, it will be a chemical reaction. What else? If we see bubbles, that means there is a gas. That's another indicator of a chemical reaction. We are trying to see if it's a chemical reaction. We said temperature, gas, what else? We said the last one, a precipitate, a solid forms. You mix two liquid and you obtain a solid. When you see that, you don't have to think much. Oh, I created something from two liquids. Okay, I have a chemical reaction. Or if a color changes. Those are signs that if you see that, you know you are having a chemical reaction. And this is it for this workshop. I will stop the recording and I will stay in case you have questions. And thank you for coming.